In this video, I'm going to be looking at an example where they say calculate the number of joules released when 75 grams of water are cooled from 100 degrees Celsius to 27.5 degrees Celsius. So what do we do in this situation? I'm using my calculator here for values that I'm going to be getting for this problem. Make sure you have a good calculator that you can use. So the first step with doing these types of problems is writing out the formula. So we know that Q is equal to M times C times delta T. The first step is write out the formula. The next step is saying M is equal to 75.0 grams of water, and then it is cooled from 100 degrees Celsius to a final temperature of 27.5 degrees Celsius. So we know the initial temperature, we know the final temperature, and we know the value of C is 4.18 joules per gram degrees Celsius. Now we have our formula, we have our values. What's next? We plug in these values into the formula. So we say Q is equal to 75 grams times 4.18 joules per grams degrees Celsius. And then what is 27.5 minus 100? Okay, so then Q is equal to, what is 75 times 4.18 times the difference of 27.5 and 100? So basically, let's do one more step. 75 grams times 4.18 joules per gram degrees Celsius times negative 72.5 degrees Celsius. Q is equal to, when you multiply all those values together, you get 22,728, negative 22,728.75. Okay, so that's what you get, joules. Now it's negative. When you have delta H as negative, or when you have a reaction giving you that negative value, that means that it's an exothermic reaction. Heat is released to the surroundings, right? Notice that the question said calculate the number of joules released when 75 grams of water is cooled. So imagine the water is at 100 degrees Celsius and now it's at 27.5 degrees Celsius, right? Something has happened. Where did that heat go? And so that's where we get this value, but we can also write the value in scientific notation. So that will become, in scientific notation, what you need is you move that decimal 1, 2, 3, 4. So you moved the decimal 4 times, right? So it's actually 2.2728, but we're going to only use the number of digits we need for this particular problem, which is 2.27 times 10 to the 4th joules. Negative. So the same principle applies with these problems. Write down the values you've been given, write down the formula that you have, plug in the values that you've been given, and that will take you to the destination. This is how you should approach a lot of these types of computational problems. But also think about the conceptual, like if you did this problem and you got a positive answer at the end, that wouldn't make sense since it said that what was the amount of energy released or the number of joules released. So make sure you also think about, does my answer make sense, right? I hope this is helpful. We're going to do a few more examples in this playlist. Feel free to subscribe for more videos like this, but I will go ahead and get us set up for number 3.